Hello and welcome. In this tutorial, I'm going to go ahead and show you how to separate the implementation of a C function in a C file from its declaration given in a header file or .h file. And after that, I'm going to compile that C file in order to obtain the .o file or object file. And after that, I'm going to develop another C file that's going to contain the main function, which is going to make a call to this function that I already compiled, and the declaration of which is there in the header file. So let's go ahead and see how we can do that. And finally, one more thing, I'm going to develop a makefile and we'll show you how to build your application using makefile and the make utility. So here we go. Okay, the first thing first, we have the declaration of this function add, as you can see, and it is given in a file named myheader.h, which is a header file. And the function is pretty simple. It's receiving two integer arguments, and the purpose of this function is to find out the sum of these two arguments, and then it's going to return the result as integer. Now we have all these macros there. The purpose of this hash if not define my underscore header has defined my underscore header is just to avoid multiple inclusion of the same header. With this, we are telling the compiler if that my underscore header is already included or defined with the compiler, then not to include that once again, just to avoid multiple inclusion of the same header. Now, we do not have the implementation of this add function here in the header file. That we usually do not do. We do not write the implementations in the header file. The purpose of the header files are just to contain the declaration of the functions. We write the implementations in a C file. So here is the C file. You can see mylib.c, and I have actually kept all these files under the same folder make. Now, if you want to, then you can always put these files in different folders. But for the time being, just to make it simple, I'm just putting them under the same directory. Okay, so this is the implementation file, as you can see, mylib.h, and that contains the implementation of the add function. So here's the implementation. It's really simple. The main thing that you should notice here is the inclusion of the myheader.h in this file. So I have this hash include there at the very beginning of this file just to include that header file that contains the declaration of this add function. That's really required. Whenever the compiler will compile this file, compiler will demand the declaration of this function, and that's given in that header. So we are including that header with this implementation file. Now you must be wondering why I'm using double quotes instead of angle brackets in order to represent the name of the header file here while I include that. Now usually we use the angle brackets when we try to include any standard header files like stdio.h or stdlib.h, but here I'm using double quotes. The difference is whenever you are using angle brackets, compiler is going to look up for that header file under the include directory of the installation directory of your compiler. But if you are using double quotes, it's going to look up into the specific directory that you are mentioning here. Now I have not mentioned any specific directory here, so it's going to be looked up into the current directory. Otherwise, you can go ahead and always mention the specific path here. Say if I write something like this, then this myheader.h will be searched by the compiler for inclusion in the C drive, under the C drive. So I'm just going to mention it like this because I have that myheader.h under the current directory. Okay, so whenever we are using the angle brackets, compiler will search for the header file under the include folder of the installation directory of the compiler. Otherwise, for the double quotes, it's going to be the specific directory that you are mentioning there. Otherwise, if you are not mentioning any path, but still you are using double quotes, then it's going to be looked up into the current folder. So now let's go ahead and compile this mylib.c. As I said, I'm going to compile this file separately and we are going to build an object file. And then we are going to use that object file for building the application. So I'm going to write the main function later on, but let's go ahead and compile this add function in the mylib.c. So this is the folder where all these files are there. So let me just give dir command there. And you can see that we have all these things there. This mylib.c is there, this myheader.h and the driver.c. I have not talked about that driver.c, which contains the main function. I'm going to do that just after the compilation. So let's go ahead and compile this mylib.c that contains the add function. So for that, we can give the gcc command -c for compilation, and then the name for that file, that is mylib.c. I'll hit the return key, and you see the compilation is done successfully. No error is appearing there. Now let me just give the command dir once again. If you are using Linux or Unix or Mac, you can give ls command in order to view the content of the current directory. So here you can see that this file has been created. That's the object file. Now you can distribute this file to someone else who needs the add method along with the header file. So you'll never need to give away the source code to your friend who desperately needs the add method for their own purpose. So you have written the add method by yourself and you have compiled that, and now you are ready to give away this object file to your friend along with this header file. So in no way your friends are going to have the detail of the implementation there. So let's now go ahead and look into the driver.c. This file contains the main function. You can see that I have actually these two variables there, and simply calling the add function by passing a and b as parameter, and then assigning the result here in this variable r, and ultimately printing the result. Now I have included that myheader.h because whenever I'm making a call to this add function, compiler will demand the declaration, and that is there in that header, isn't it? So I have included that header with this program. Now let's go ahead and compile this file, driver.c. We're going to use the same command, gcc -c, and then the name for this function, name for this file, and that is driver.c. So that gets compiled. Now if I give the dir command, you can see that we have another O file, and that is driver.o. So earlier we built the mylib.o that contained the add function. The compiled version of the add function is there. Now we are compiling the driver.c file in order to get that main function compiled. And here in the main function, we made a call to the add function. So that is compiled successfully, but we have not built the application or the exe yet. That we need to do in order to execute our program. So let's go ahead and do that. In order to build the application, let me first clear this screen and then gcc -o. That's the option that you should give while you want to build the application. With this -o, you're going to tell the compiler the name of the application file. And I'm going to give the name as myapp. And then we need to mention the object files. The first one, driver.o, and the second one, mylib.o. You can mention them in any order, doesn't matter. Okay, so hitting the return key, and you can see that it's compiled successfully. Dir command to get the detail of the directory, and you can see that myapp.exe is there. Now if I run that myapp.exe just by mentioning the name and hitting the return key, if you are on Linux platform or Unix platform or on Mac, you just need to type /myapp. But here myapp only is going to work fine. So you can see that it's running well. Now I hope you have understood what I did. I want you to do this thing practically by yourself, step by step. Just create all these three files and put them under the same directory, and then go ahead and compile them separately, one by one, and then just build the application and you'll have fun. And I hope you have understood how the things are going on there. Lots of commands that you need to execute. There could be some more dependencies. You may have some more functions to call, and which may be on some different header files. So the things may be complicated. Now in order to do away with this kind of complicacy, what we do, we actually build a makefile, and the makefile contains all the required commands in order to build the entire application step by step. So you just don't need to do the things one by one into the command prompt. Rather, you are just going to build a makefile once and can reuse that makefile whenever you need to rebuild the application. So let's go ahead and see how the makefile works there. So all these commands that I just executed, we are going to put them in the makefile, and that is a kind of a batch job. Not only that, in a makefile, we can clearly mention the interdependencies for building the object files. Manually, it will be very hard and complex to remember these interdependencies. So once you are done writing the makefile, you can reuse the makefile for building your application whenever you need to do so. Let me explain what I mean to say by the term interdependency when we want to build an object file from a C file. Let's consider that we have this C file a.c, and there we have a function a, and from within that function we made a call to these two functions b and c. And the definition of these two functions, or the implementations of these two functions, are there in these files. b.c, that contains the implementation of the function b, and c.c, that contains the implementation of the function c. Now for each of these C files, we have corresponding header files containing the declaration of these functions. So for c.c, we had this c.h that we have included here in a.c. So hash include double quote b.h, and of course hash include double quote c.h. We did them perfectly. Now you can see that there is a clear dependency. This a.c is dependent on this b.c and c.c. Now while building the entire application, the object file for b.c and c.c must be available. Otherwise the application could not be built, right? So this is what we call as interdependencies. Now this kind of interdependencies could be many if you have more than one C files there. And remembering all these interdependencies while compiling them step by step will be really a hard task to do. Rather, we can actually mention all these things in a makefile. And once you are done building the makefile, you can use that any numbers of times you want to rebuild your application using the make utility. Let's go ahead and see the makefile now. Okay, so this is the makefile that I already have built there for building this application my app. Now you can see that the first label here is the all label. That's actually going to tell the make utility that in order to build the my app, we want to build all the object files and all the build requirements first. So next we have this my app label, and that is going to tell the make utility how to build the my app. And here we are clearly mentioning the dependencies for building the my app. So it's telling that this my app is actually dependent on driver.o and mylib.o. And then we have this gcc command in order to build the entire application by linking driver.o and mylib.o. Now this is exactly the last command that we gave there in the command prompt directly for building the entire system that we are putting up here. Now you can see that here we are using the option -o for building the application, and that's actually a typical option for linking the object files and building the application. And then we have this new thing here, -wall. That's the extra thing that we are having here. And that's nothing but telling the compiler to print all the warnings that may appear during this linking period. And then here is the driver.o label, and here we are saying that in order to build this driver.o, it is having a dependency on driver.c. That's required for building driver.o. And then the command gcc, that's actually telling how to build that driver.o using this driver.c file, and we have the command option -c for compilation there. And then how to build that mylib.o, so that is having a dependency on mylib.cpp, and then we have this command in order to build the mylib.o file. And after that we have this clean level, and that is going to tell the make utility to execute these commands, and these commands are going to remove all those O files, because once we are done building the application my app using the O files, then we no longer need those O files to be kept there in the folder. Although you can just remove this clean in order to keep these O files, that's not going to make any harm, but since we do not need them anymore after building the application, once the application is built, so we can just go ahead and clean them. So that's the last thing that we have here in the make file. Now we need to apply the make command in order to build this my app. So from the command prompt here, we just need to type make and hit the return key, and this make command is going to find the make file there under the same folder, and it's going to use that make file in order to build the application. But for the time being, since I do not have the make utility installed in my system, so if I hit the return key, it's not going to work. You can see that it's telling me make is not recognized as an internal or external command. That's just because I do not have the make utility installed in my system. I need to download and install that, and I'm going to show you how to do that. But if you are using Mac, Linux, or Unix, you may find the make utility already installed on your system, and you can just go ahead and type the make command in order to build the application using that makefile. Now let's go ahead and see how we can download and install makefile on Windows. Okay, just open up your browser and using your favorite search engine, just go ahead and type download GNU Make for Windows and hit the return key. Now the first link, that is what we are looking for, is actually GNU win32.sourceforge.net/packages/make. Just hit on this and it's going to take you to this page, and there, if you scroll down a little bit, you are going to find this download subheader there, and under that you are going to find this setup. Just hit on that to get it downloaded. Now when you hit on this setup, it's going to actually ask you for the location where you should save this make utility. And if I wait for a moment, and there you go, you can see that it's asking for the location where I should save this make 3.81.exe. So I'm just choosing my download folder and hitting on save, and that's downloaded successfully. So I'm just going inside of this folder, and there you can see that this is the utility. This is the file that we are looking for. Now I'm double clicking on this to get it installed. Just follow the procedure. You'll be asked using a system dialog to proceed or not. Just hit on the yes and you'll proceed with the installation procedure, and just hit on the next buttons. By now on this dialog, you're obviously going to accept this license agreement. Hit on next and choose the location there. The default one is fine. Hit the next again and next once again. So I'm hitting on this next and then next and install. So that's going to install make utility on my computer, but still we need to set up the path. Still, if I just go ahead and type make there, it's not going to work unless and until we set the path and tell Windows where make.exe is in my system. Windows will not be able to recognize that. So let's just go ahead and open up the file explorer there. I'll go into the C drive, and under the program files x86, GNU Win32, under that we have this bin folder, and under that we have this make.exe. So this is the installation directory GNU Win32, and under that we have this bin folder, and under that we have this make.exe that we need exactly in order to use that makefile. So here I'm just going to hit on this yellow icon to get the entire path. I'm just going to copy this, and then in order to set the path we need to go to the system variables list, and for that just right click here on this PC icon, and then just hit on this properties and then advanced system settings. This is actually the system dialog box. You can actually come to this system dialog box from the control panel as well. So just hit on this advanced system settings, and there in this dialog box hit on this environment variables, and there under the system variables list, if you scroll down a little bit, you're going to find this path, and then hit on this edit, and in this dialog box you need to hit on this new in order to add the new path. Then here just paste the path for the make.exe that we copied earlier. So now just hit on this OK, and then OK, and then OK, and we are done. Now if I go into the command prompt and type make, still it's not going to work because we need to restart the command prompt in order to make the changes effective. So I'm just going to go ahead and exit from here, and then I'll just type cmd once again in the Windows search box, and then we open up the command prompt, and we need to go inside of that folder, our project directory, and that's under C drive. And then we need to go inside of C 2019, and under that we have this folder make. So I'm using cd command in order to get inside of the folder, and we are here right now under that make folder, and inside of the make folder you can see that all these that we created earlier. So I'm just going to delete all those O files and exe files. So I'm just going to delete the O files. So this is going to delete all the O files, del start.o, and then I'm going to delete all the exe files because this time we are going to build all these things by using the makefile. Now we do not have all these files there, only we have these C files and the header file and this makefile. Okay, now let's go ahead and apply the make command. So here we go. make, and I'm going to hit the return key. So we have some error there. It's clearly saying no rule to make target mylib.cpp. That's a typo actually. There is no file named mylib.cpp. It's actually mylib.c. So we just need to correct it here. You can see that under this particular label, we have this mylib.cpp, but it should be mylib.c. Let me save that. And one more thing that I want to correct here, we just don't need to have this one, that clean label, because this rm is not going to work under Windows. That's a Unix command. Okay, so I'm just cleaning that, and it's going to have those O files there under the directory. No harm in having those files there. So let me just apply the make command once again, and you can see that this time it's working fine. So if I just provide the dir command, here's the outcome of the dir command. You can see that we have this driver.o, then this myapp.exe, and then this mylib.o. All are created. Now I can just go ahead and run the program by typing this myapp and hitting the enter. So that is how we can actually build a makefile and the make command in order to build the entire application. That's going to make the building process really simpler, especially if you have many interdependencies in your program. Then it's suitable to use a makefile. Thank you for watching this.